Welcome to this presentation by Automatech. This topic is why OEE as a metric. OEE, or Operational Equipment Effectiveness, is a way of measuring how well your facility is doing in its manufacturing environment. Today's focus will be on the packaging environment, but it certainly can extend to other disciplines throughout the plant floor. We're going to find out that the main issue is to maximize the visibility. And once we do that, OEE becomes more than just a number, it becomes a call to action. To dive into this further, we've split this up into a couple different topics. The first one is just discussing the value of OEE from a very high-level overview. Then the next one is to maximize visibility. That's where OEE really comes in play. In order to illustrate how we can set up an OEE system at your manufacturing site, we've created a system design meeting to mock through a packaging line to better understand what are the components that we need to consider when putting together a system. And finally, we wrap it up with some typical customer outcomes for how you can expect to see the advancements in your facility. But first, allow me to introduce myself. My name is Christopher Carlins. I'm a senior application engineer with Automatech. Automatech has been around for 20 years with a large suite of products that are ready to help any manufacturing environment. One of the key focuses is the GE Prophecy Suite, which we're here to talk about today and help your manufacturing environment be the best that it can be. GE offers the Prophecy software suite, which helps manufacturing environments improve in many aspects, from the machine floor all the way through to reporting at an enterprise level. They offer efficiency, quality, and production management solutions throughout the world and have helped hundreds of customers achieve better results in their manufacturing process. So let's start by discussing just what is the value of OEE, or Overall Equipment Effectiveness. OEE is a metric that can tell us whether we're doing better or worse, and basically begins to open up visibility into our system. Once it's fully realized with automation and additional manual information applied, we can see drastic gains in profits through solving issues and making the system more predictable. So we can have a reduce in downtime. We can have an overall improvement just because everything is more orchestrated. And we can decrease scrap rates and therefore better utilize the raw materials that we have access to. So we want to do things like increase available runtime, reduce the reasons why we have to kick product off and not be able to ship it out to other customers, and in general just improve our production output. All of these things can relate directly to the bottom line, which is why this OEE story speaks so strongly to many. Now let's dive in a little deeper and explore what OEE is and understand why it has to be more than just a number, but really a full system that acquires and compiles data into an analytical point of view. So right now, I can walk into any manufacturing environment and help them without any automation discover what their OEE number is. In this example, we just need a few things and we can discover what our OEE is. So if we have a shift for 8 hours and we have 100 parts per minute, then for that shift we would expect to produce 48,000 parts. Well, later on, after we count up all the different pallets and discover how much good we had produced on our pallets that we can ship out, we counted 24,000 parts. Maybe it's the next shift that we were able to determine this. So we could say, well, yesterday's shift was 50%. Is that number good? Is it bad? Again, it's just a relative number. Could we always do better? Most likely. We can do things like compare this number to other time periods, even a full week's production. So we can say over that entire week, 2 shifts per day for 5 days, we have 480,000 parts that we'd expect to produce. Once we counted up all the pallets, we could discover the first pass good that we can ship out is 235,000 parts or so. And so that gives us a weekly OEE of 49%, which again is a relative measure. One way we can relate to this is, how did we do 1 year ago with this type of manufacturing? And we could see that back in our history, we were at 45%. So maybe some basic initiatives, some additional training, some more experience with the operators has gone into making our system better. We can tell it's better, but we can't really say why. We don't have any records of downtime events in the past versus now. We don't have records of what the ideal speed was. We just know that we're doing better. And that's the whole point of this conversation. We can get that OEE number very quickly, just on paper, and it can tell us if we're doing well or doing worse. It's like a thermometer when you're sick. You can tell that you're not feeling well. You can quantify it, but you don't really know the reason for it. You need help. So you need a doctor. You need someone walking around with some analytics, with some more detail. And that's what we can do as we drill down. So you can see the next layer underneath OEE is availability, performance, and quality. All we're really doing is taking that calendar time of a shift and breaking it down to the different reasons why we're having issues. So availability are your large downtimes. Well, we had a motor failure today. You know, we had some additional time for changeovers. Maybe that's part of your OEE metric. And then for performance, well, we had to run it a little bit slower because the operator's still learning how to run the machine. Or, as mostly the case, we had a death by 1,000 cuts. A whole bunch of little minor stops that stopped the system, started back up. We had the ramp up issues. Maybe a sensor kept malfunctioning. Maybe an operator kept opening up a safety door. These are the types of things that we want to try to bring to the surface so that we can say, what are the big pains that we're having today? And how can we improve them over the lifetime of an operator or a process? That third bucket is quality. You can imagine when labels aren't being put on properly, when the caps aren't being put on, maybe it's not filling to the right volume. These are all reasons why we have to kick them off. Any time that we're spent creating bad product, we're wasting time, and that's the key, time. We want to maximize our time, and we're going to do that by adding detail to find out why the process is suffering so we can spend more time making the right product. Let's talk about a little bit more about how to calculate OEE. In this example, you can see, again, we know how much we produce, which is the good, and we know how much we were supposed to be scheduled for, which is that 8-hour shift. We know that we didn't completely obtain our numbers. We can see the ratio is about 50%, but we don't know why we went down. What were the exact ratios of downtime and waste, and what were those reasons? So let's start quantifying that information. And some people do this already with clipboards. Let's start obtaining this information. Let's let the machine tell us the reason why it went down and why, and the exact duration for those different reasons. So that ratio between the total scheduled time and the smaller green bar there is essentially your availability. Any time that you didn't spend running is that downtime. And we want not just that, but we also want the ability to drill in and see the different reasons for that time period, why we weren't running, motor failures and things of that sort. The next ratio is the larger green bar with the smaller green bar again, and that gives you your performance percentage. So we can look at that performance percentage straight up as its own metric and say, hey, am I lagging behind? And then I can drill in further to see, is it minor stops? Is it the operator running it slower? But that ratio there of produced versus operational time is what triggers us to drill in a little bit further. And finally, with quality, again, looking for those kickoffs. How much time do we spend wasting product and not making the good stuff that we need to? So what we've done is filled in the blank, and we can see how much is good and how much was wasted for other reasons. It should all add up to that scheduled time. Just as a final note, you'll notice that if we cross out operational and produced time, and when we multiply these three together using some basic math, we cancel out the numerators with the denominators, and you can see how the scheduled versus the total good of our availability, performance, and quality is the same as if we were just looking straight at the OEE. And that's why we can multiply those three numbers together. So in summary, in order to find answers to a low OEE, we need to increase visibility. We need to find out where the pain is. So from a downtime perspective, how often are we down and why? Well, if we automate this, we can know every single duration. And that goes for those minor stops that hit against our speed loss performance rate. Now that speed loss can also be running slower, but again, we want to be able to distinguish between those two. And right there in the middle are the main reasons for waste. Why are we not able to produce product that's good? Why aren't they going into the final pallets? Lost labels this week, bad glue next week. These are the answers that we want to keep on top of so we can keep making actionable decisions. Finally, from a standpoint of visibility, we want to look at things by what type of product is being run. The shift time, is it the day crew is being managed different than the night crew? What can we learn from each other? And that goes for those crews as well. By having those shift meetings, by analyzing the information and knowing where training is needed, we can empower the operators and allow them to take pride in doing better than they did last year, helping the company be more successful and more predictable. So let's turn to our hypothetical situation of a packaging line and see what can go on in a system design meeting to help tackle those key topics for a proper OEE implementation. I'd like to propose that we start with one small step. Pick one production line or even just a machine, maybe just that key filler, and down the road we can learn to expand to similar lines and bring in more of that configuration quite easily actually. But what we want to focus on along the entire way is to automate the data collection as much as possible. We want to provide the operator with as much actionable information without burdening them with additional work. So in this diagram, what we see is we want to initially start with an OEE loss visibility. We want to know what's going wrong with these machines and how can we fix them. We're going to gain traction by improving this over larger portions of our environment, getting more people involved with this new concept of visibility through OEE. We can start delivering results, applying it across the entire plant, and it's going to make us more predictable. We're going to be able to add our schedules on time. We're going to be able to do more with less raw materials, with less machines, and we're going to move our way towards an overall business alignment, an enterprise manufacturing system that goes beyond just efficiency, but reaches into the quality side, maybe in our batching and production management for scheduling and even genealogy so that we can do proper traceability. So when we're doing our initial assessment of which software package to choose, let's choose one that is a single platform, is integrated and ready to go beyond OEE. Let's not dead end ourselves with a smaller package. Here's our hypothetical situation. Our design focus is a filler, packer, and palletizer. The filler in our hypothetical situation is fully automated. We've bought a state-of-the-art machine. It tells us when it's down and why. It counts everything for us, and it even has counters for kickoffs. But we just haven't tapped into it yet. We still have people writing down information on clipboards. Then the packer has some automated data, and the palletizer is completely manual. But the point of this exercise is to understand the different places where an OEE system can be applied, even in those manual situations, so that we can get all the data in one place. So as I said, even for our filler, even though it's fully automated, we have people writing down downtime on a clipboard with approximate times for when things started and ended and what type of downtime it happened to be. Notice that we also have reasoned comments so the operator can interpret what went wrong at that time. Typical things are guidelines for, don't bother with any downtime under 5 minutes. And oh, by the way, if you happen to have a minor issue that happens a lot, we'd like to know about that. So if you could estimate the duration, throw that in there as well. So not very scientific, but certainly better than nothing. What I'd propose during a design meeting is to design a reason tree. And this could be used for paper, but it really applies well when you're digitizing your information. Notice that we have 3 levels, a type, a reason, and a detail. So we structured the tree. Our type would be we had a production downtime and it happened to do with the operations. Maybe the operator had to clear out a bottle jam. So we could see every one of those minor stops if we were to record this data and see how often the mean time to repair the bottle jam is, which is probably quick, but the mean time between failures, that's where it's important. How often does this happen? We can also include all the other downtime that's going on with that machine. Did we have scheduled time off? Are there changeovers? Maybe that isn't part of our OE, maybe it is. That's all part of the design system. What are we going to incorporate as part of our OEE? So The final part to a reason tree is to apply these categories. Which ones are going to affect the availability portion of our OEE? Those are our major stops. Which of the downtimes are going to affect our performance ones? Those are our minor stops. And what are we going to remove completely from our OEE? From the standpoint of that filler, if we're being blocked by the packer downstream, well, for that piece of equipment, we're not going to count it against the OEE of the filler. Those are examples how we use those categories. So moving to the first piece of equipment on our hypothetical line is the filler. As I said, it's fully automated, so we can take advantage of a run status and a fault signal for the downtime. The machine is going to tell us when it's running or getting a value of 1, and when it's stopped or getting a value of 0. So right off the bat, we're able to know every time a downtime occurs and its exact duration. Another thing that we can do is acquire its first out fault. So maybe a sensor tripped, maybe someone hit the emergency stop button. Those faults come in as codes, and what we want to do is be able to take advantage of those codes as well. In a similar fashion, we have waste and production counters. These can either be represented as a square wave every time a can passes by its sensor, or it can be as a step wave that just increments every time that sensor is triggered as well. You'll notice that what we can do for the waste is have tags or sensors for every time a can is kicked out for a specific reason. So now we can start quantifying how many times product was kicked out because of a label and how many times it was kicked out because of a low fill volume. Turning quickly back to that reason tree we created, we want to be able to take advantage of those fault codes coming in from the filler. So what we want to do is have a translation table. Fault code 222, which is for a filter change, we'd want to line up with our reason tree for down because of filter, and so on. For the motor failure, the clog, bottle jams, anything that we can have as a value coming in from the machine filler, we can translate into a reason, and now we can quantify those reasons into a bar chart. Moving to the second piece of equipment on our filling line, there's the packer. Now here we have the ability to monitor downtime, but only its status. That means that we know when it's running or not running, but we don't have a fault value to know the reason why. So in this case, one of the things that we can do is either just acquire that information and know how many minor stops we have versus major stops, or what we can do is allow an operator to interact with any of the larger downtimes. So every time we have a downtime over 5 minutes, let them press a button to help us know why that value is happening. In other words, we're taking advantage of the machine interface that's already near the packer to have the operator type in some more information and have that information directly be integrated into our efficiency system. Now, we can do something similar for waste. In this case, our packer has no automation for waste kickoffs, but if we have many of them, we can have the operator use a waste entry screen to also keep track of that information as well. And finally, with those production counters, we do have some automation coming from the packer, and that includes knowing every time a case has been created. So we'll take that in as part of our system analysis as well. The final piece of equipment on our packaging line is the palletizer, which is basically a manual process of stacking cartons onto a pallet and then shrink wrapping it. So there is no machine downtime data, but we could still use the clipboard to keep track of information over 30 minutes so that we can know when major issues occur. Or we can even incorporate an iPad into the situation so people can put the information right into a digital form right at the palletizer. Similar for waste, we don't really have waste per se, but moving on to the production barcode scanners, every pallet that's created produce a label, we put it on there, but why don't we scan that label into the system and also include a status so they can scan whether it's going into inventory or if it has to be put on hold and so on. In other words, we're keeping track of every time a pallet is produced in real time, going right into the system, and we're able to tell the status of that pallet so we know if it's going to be counted as part of waste or rework, or if we need to have someone come over after 3 or 4 of them have been put on hold so that they can intervene and push them through the system and move on from there. So in summary, our implementation of the filler, packer, and palletizer has a couple different aspects to it. We're going to utilize as much automation as we can, so that means at the filler, we're getting a full OEE right from the system without having to ask for the operator to do more. In fact, we can tell them to put those clipboards aside. As for the packer, we can still track the downtime durations and ask for the operators to press a button to determine why a downtime event has occurred. Again, it all comes down to how much do we want to burden the operators and how much information do we need to know. And finally, for the palletizer, we're definitely going to take advantage of those barcode scanners to track inventory in real time and be able to produce a report at any time to know what is the current inventory status of all the different pallets I have on the floor. A lot of valuable information there even in real time. We can use it for analytics as well. Let's turn now to some typical outcomes that customers have seen just by utilizing an OEE package. So let's review what we do get with a fully implemented OEE system. The big focus, again, is on automated data. That means the machine is telling us when it's going down, when it's kicking off waste, and how fast it's running its production versus its ideal rate. So the information is much more accurate, and we can start pulling analytics out of it and also alerting people when things happen to be going wrong in real time. So that means less of a burden on the operators. They can focus on doing the job they need to do. Where needed, however, we can still ask the operators for some additional manual information. We're going to ask them to put information in through a machine interface, a configured screen that comes with the efficiency package, maybe even just an iPad. But the point is we're going to only ask them for information that we'll find really valuable. And rather than just being on a piece of paper that ends up in a filing cabinet, this is going to be information that's digitized and brought in directly with all the other information that we're acquiring automatically, available in real time to anybody else to see. And from that, we get control. We find that downtime is greatly reduced, both in major issues and with operator training for minor issues. We're able to monitor the quality of the product in real time. That means that if we're having a bunch of kickoffs for a certain type of issue, we can alert someone and become more aware of the situation so that we can address those issues. And all of that leads to a higher OEE the next week around. One of the things you want to look for in an efficiency package is standardized reports. These are reports that are ready to go on day one. After the implementation session and configuration, all of that automated data and the information that people are manually entering is available in real time right through a standardized report. It's also understood that every customer is going to have their own requirements for what they want to see in a report, whether it be a dashboard or a 30-day production report. We want to be able to slice and dice the downtime data, the wastes. We want to be able to show it to the operators so that we can train them for next time. And we want to be able to see possibly an hour-by-hour trend that showed how did we do that hour and what might be the reasons why we weren't functioning properly. Everyone's got their own story, and you want to pick a software package that's able to create those reports on the fly and get the operators motivated to do a better job. Discussing OEE theory is good, but let's take action today. That's what I want to do with this OEE starter kit, to gain visibility and take control. Right off the bat, we know we want to just get in there and design a system. So it comes with a virtual machine that's a server with all the Prophecy software on it ready to go. And then we just jump right into services. We come in for a week or two. We have a consultation session right off the bat, which has a great value for understanding what your machine has available to it, what we can take advantage of. And let's talk about those reason trees, fault translation tables, how to automate the data to make it most effective for your operators. Now this also includes configuring the recorded data right into the system, all the other system implementation to get it up and running, and that talks about to the configuration of the out-of-the-box operator interfaces, what reports are available, and then we go into a little bit more about what kind of reports would really be effective at this facility, what would motivate the operators, and what would give the managers the monthly reports they need in order to take action and make their system the best it can be. And of course, the system will allow you to grow with it. So we're going to start with efficiency. We're going to be able to expand, and then we're going to be able to talk about an enterprise solution down the road when we want to increase that journey to be the quality information of your batching system, or using traceability and scheduling to make your system more efficient at a higher level. This is the start to an enterprise solution. Thank you for joining us on this presentation of OEE as a metric. We hope you found it helpful to learn how OEE can be more than just a number, but can be used to maximize visibility and help you take control of the process. If you'd like to learn more, I invite you to join me over at booth 1368. I'd love to have a private conversation about how we can utilize this technology at your facility and increase your OEE today. Please note there's also a presentation tomorrow by GE. It's called The Power of 1%. It dives deeper into this topic of efficiency and the larger topic of operational excellence for the entire manufacturing world. Thank you.